Hello, welcome to another R tutorial where we're going to look at two categorical variables. In particular, we're going to look at three ways of examining two categorical variables. That is, one is in terms of contingency tables or a cross tabulation of two tables of tables rather, and we're going to look at percentages and as well as counts. Another way of looking at two categorical variables is the use of mosaic plots, which is less common actually, but I think you'll find it to be rather informative because it's a way of graphically representing both on the x and y axis of a plot the distribution of two categories. And it's very useful, I think, statistically, although it's not as often used as, say, the last thing we're going to look at, which are bar graphs, where we can examine two plots, two categories by percentages or proportions using bar charts. So we're going to revisit our familiar data set, which is and familiar syntax, which is going to be our Titanic data set and the syntax that we have using the Mosaic library. So let's make sure we have our first, let's make sure that we have our Mosaic package installed. So we're going to type, and it looks like we don't, so we need to click on these two. And we'll see that these should be attached now. So these should be here. Well, it looks like it thought they weren't attached. So let's just do that anyway. Okay. So we should have both of these attached, and we actually see that to be the case. So now we're going to, if you recall, we can view the Titanic, and we have several categorical variables. But we want to actually scroll down, and we're going to look at, within the syntax, we're going to look at creating contingency tables for two categorical variables using this tally function. If you look at an earlier R tutorial on one categorical variable, you'll see that this is quite familiar. The only difference here is that we have something called an operator, which is simply what you do to certain parts of a function. In this case, you're telling R that you want to look at the both the categories of class and survival, and you want to look at counts using the Titanic data set, and margins you're going to establish to be true. In other words, and this is a very common way of presenting an argument. I like to put spaces between operators simply because it's conventional. When you read a lot of syntax, it's a little bit easier to read. But you're going to say this margins is actually another way of looking at the contingencies. In other words, what is the count of those who survived based on their class and vice versa? And we'll take a look at that here. And you're going to see that print in the lower left-hand corner of the screen, which is in our console. I'm just going to press Control-Enter to run this. And what I mean by contingency is you'll see the margins here. You'll see that you'll see a total for both, for each level of class, but you also see the contingency for each category. So you'll see the number of people who survived. So if you're interested, so for instance, in say what number of people, what category of people had the most deaths or least amount of survival, you would say, well, most people who died in the largest category, rather, of passenger deaths within the Titanic, among the total number of observations, and you can verify this by looking at your environment here, you'll see that of the 1,045 passengers, the largest number of passengers in looking at both categories, you'll see is in the lower class. Now, that's different than percentage, and we're going to look at that. We'll look at the proportion here as well. So we want to know, say, what proportion. Well, of course, that's a little messy, so let's try to round this. And if you recall, I typed before the round function, and of course, it's complaining now because we want to put a comma there, and we're going to round this to 2 decimal places. I'm going to save this script, and I'm going to run this right here, and you'll see, okay, well, now you see in a table, you'll see that this hopefully will make a little bit more sense, that you'll see that the largest percentage actually of all passengers were actually of passenger deaths. 35% of all passengers died were were those who had died and were also in lower class. So if you look at a two-way contingency table, you're actually looking at proportions that all add up to 100% right here. Now, if you want, and that's what the plus sign does, looks at the conditional on both categories. Now, if you want to look at a table of proportions conditional on one variable versus another, in other words, you want to say, given one variable, maybe you want to know the proportion of an outcome. So we'll again use the round function. I think it'll help with for interpretation. But I want you to emphasize the fact that we're changing one aspect of the syntax here that is quite relevant. And this is this little thing here. It's called a pipe or vertical bar. What this says actually is that conditional on conditional on survival. Actually, let's reverse this. Let's do conditional on class. What is your probability of survival? So we'll use survival as the outcome. What was the error here? We'll have to rerun this and see what. See, this is another key element. Survived. You want to make sure you have your variable names correct. So you'll see that this asks a different question. This is why order matters, and this is why that tilde is important, because it actually says, if you can translate this to a sentence, I'm going to bracket out this part here. One way is to think about this linguistically. What you're asking R to do is to evaluate or understand what are the proportion of those who have survived, given that we know which class they're in. And we're using the Titanic data set. So in other words, we can identify, first we want to look at the column and we say, well, okay, we want to see, given that we know that you're in the upper class, what's your probability of survival? Well, it looks like 64% or 0.64 out of 1 have survived. Now, among the lower class, you'll see only 25% in the lower class have survived. And in the middle class, you see something somewhere in between. I think to be a little more intuitive, we can tally this as a percent. And you'll see that this is maybe a little bit easier to understand. I'm going to put a little 0 here just so you can see those raw numbers. And this is the difference between that pipe operator and that plus operator. The plus looks at a contingency on both the rows and the columns, whereas the pipe here, the vertical pipe, is looking at a one-way contingency or a conditional distribution. So the pipe looks at the conditional distribution, the plus sign looks at that joint distribution. So quite often we're interested in, say, the conditional distribution, or often what is called the marginal distribution. But let's use conditional, because it's language I think that is a little bit more intuitive, which says, given that we know which class you are in, what does that tell us about your survival? Or we could even say, see something like gender. I want to make sure that that's the variable name here. Yep. So we'll see if there's actually any association between that. And you'll actually see, well, actually, lower class, people in the lower class, 70% of the lower class was actually male. So there is an association between gender and class position as well. So that's conditional as well. But let's change this to a plus sign, and you'll see quite a difference in the way that this is presented. Here you see the percentage of both being an upper class and male, and that the values here within these these 6 values, these all add up to 100%. In other words, what this says is, given both lower class position and your category, what proportion of the total sample, what percent rather, comprises males of lower class? Well, we see that 30% of the passengers were males of lower class. That's a joint distribution because you're looking at both the categories of class and the category of gender. Now, we have only a few more minutes, but I want to emphasize here just this. You can look at the syntax. We're going to look at the bar graph. I'm going to show something to you that's relevant, and then you may encounter this issue If you creates a plot window that is too small, it may look a little squished. That's all. But you'll see that it still should be evaluated. Sometimes, however, when you make your view a little bit too small, and we're going to make another graph here of survival. In this case, it doesn't matter. You may have issues actually viewing the graph, and you may get an error message. If that's the case, make sure your window, your plot pane is large enough. Here you see, I'm going to use the back arrow to go back to what we had seen before. These are bar charts looking at the number of those by social class who have survived. And here you see maybe a different color scheme in your own syntax. But the point here is you're looking at social class grouped by survival. So you're looking at survival by lower class. In other words, here you see among those who did not survive here, so this is your legend or your key for survival for the grouping variable. You'll see that the people with the fewest survivors were actually the lower class. Now, quite often, I want to show this to you. This is a Mosaic plot that shows the joint distribution of survival in class. That is quite useful, but I think requires a little bit of explanation. Here you see the x-axis, and this is actually the size of that distribution. If you recall, when we looked at one-way distributions, the largest class actually was the lower class. Let me go back to the counts here. We're going to go up here, and we're just going to tally class. We'll do a percent here. You'll see that the largest percentage here and the largest number of passengers, that large proportion is in the lower class. Well, that's indicated in the Mosaic plot by the width. So width is the size of that, relative size of that category in the x-axis, the class here. Well, what is the y-axis? Well, it's also the relative size. So if you have two dimensions of size, the area of a Mosaic plot gives the relative joint distribution. So here you see the lower and lack of those who did not survive. You'll see that that's quite large, and you'll see that it's quite small. This is, in fact, the smallest area in the Mosaic plot for that joint distribution of mortality and being in the upper class category. Let's see. So here we are looking at this. I don't think there's anything else we want to talk about with a Mosaic plot except that you can swap that joint distribution and actually look at it in different ways, and that the x and the y-axis actually look quite different. And this is relevant. So here we see all we're doing is we're swapping the order of the distribution. Here you're seeing conditional. You see the distribution of the survival or not, and then you see social class. So that's, I think, really the end of the code here, and I hope you found this to be quite useful. Thank you very much. Oh, and I do have to say one more thing. We'll actually look at this. I'm going to show you briefly. We're going to look at stacked bar charts. What is a stacked bar chart? Well, here you just add an argument here that you specify to be true, and that you're just going to stack these categories. What do? You stack the survival categories. If you want to specify that to be false, you're just going to show that that grouping variable is, as we had seen before, they're different, they're spread out. This is useful when you're looking at maybe categories that have multiple values, like social class by another categorical variable, like 3 or more categories. And then here's another example of how swapping survival and class represent the data quite differently. So here you have the total count, and you sort of have the stack of that count for the survive and those who don't survive. So here you have a little bit of insight into the data in a different way than if you had stacked them this way. Right here you're looking at, you're really emphasizing the fact that, sorry, I didn't meant to stack that. So let's specify this as true. If we stack our bar charts, we're emphasizing that the lower class had the highest count of mortality, and relatively equals largest overall size. If you look at the stack bar chart for based on the grouping class of grouping by class rather than grouping by survival, you'll see a different representation of the data. So here, again, we're emphasizing that the order matters, several of these arguments matter, and that quite often, we'll elaborate on this later, this true and false element is important. And the auto key here is simply a specification of the legend. We can turn that off. This is what the true and false measure do. You'll see we just created that with that being false, and then here it is specified as true. And then you just add that bit of information there. So here we reviewed quite a bit of information, but I hope it's useful for you. Contingency tables using the tally function, Mosaic plots using the Mosaic plot function, and bar charts. And here we looked at examination of proportions, percentages, counts, both as joint distributions and as other ways of visualizing data. And I hope this has been useful for you. Thank you very much.